What's going on, guys? In this video we are going to see how to solve this first order differential equation. Here we have a piecewise function. Here you can see when x is 0 to 1 we have 1, and when x is greater than 1 this is 0. Okay, now let's go ahead and do this part, because this is the initial condition given right here, so we always have to start with whatever the initial condition available. Now y of 0 mean when x is 0 y is 0. Now when x is 0 mean this is under this region, because this region is 0 to 1 and 0 also included, because they have mentioned that x is greater than or equal to, right? So 0 is included. That's why we had to use this one first and solve this first order differential equation, and then we are going to see this condition later. Now in order to solve this one, first we have to write our first order linear differential equation, that is dy by dx plus y, and this is the f of x. F of x is equal to 1 for the first one, so 1. Okay, now this is already in standard form, because the standard form of the first order differential equation should look like this: dy by dx plus p of x times y plus, that's equal to q of x. This is the standard form. If you look at this one, this is already in standard form, so we don't have to do anything. First thing is we have to find out the p of x value. P of x value is whatever the value that's multiplying y. We don't have anything here, it means it's just 1. So here p of x is 1. After we find out the p of x, we have to find out the integrating factor, that is using this equation, e power integral p of x dx. Since we know p of x is equal to 1, we can just plug it right here and find our integrating factor. That's going to be e power integral 1 dx. If we do the integration, that's going to be just e power x. Okay, don't worry about the constant, because we don't need it, because we are going to multiply both sides. The constant will cancel anyway. Okay, so we don't have to worry about the constant. So after we find out the integrating factor, we have to multiply both sides of the equation by the integrating factor, that is e power x. If we do that, this is going to become dy e power x over dx plus y e power x is equal to e power x. Now if you look at this one, if you do the derivative of this part e power x, and I separated this y, you will get the whole thing back, right? That's the purpose of this integrating factor, because after we multiply by the integrating factor, the derivative of this one is going to be the whole thing, because that's a chain rule. So by chain rule you will get this one back. So we don't have to write the whole thing again, we can just write this one and equalize that one to e power x. Now after we multiply by the integrating factor, we had to integrate both sides with respect to x. This side also with respect to x. If you integrate this side with respect to x, integration and derivative cancels each other. So we will be left with y e power x. In the other side, if you integrate e power x, that's going to be just e power x. So we will get, let's continue here. Let's use a different color. So finally we will end up with y e power x is equal to integral of e power x is just e power x. But at the end we have to add a constant. Let's put this one c1, because here we have two conditions. One condition is this and another condition is this. So when we have situations like this, we have to use c1. It's better to use c1, c2 and something like that. Here first I use c1. Now we have the initial, but before I go ahead and apply initial condition, let's bring this one in terms of y. That's the first step. Now in order to bring this one in terms of y, we have to divide everything by e power x, because we have an e power x right here. So divide everything by e power x. It's going to give us y is equal to 1 plus c1 e power negative x. Okay, now this is the one we derived from the first one, but since we have the initial condition, we can find out the particular solution. So here what it says, when x is equal to 0, y is 0. So let's go ahead and plug this in this equation. When x is equal to 0, that is this one, 1 plus c1 e power, instead of x we plug 0, so negative 0, that's going to be just 0. And y is also 0, right? 0 is equal to this. So from this one we can derive c1 is equal to negative 1. So we found out the c1. Now after that we have to plug back in this equation and express our particular solution. That's gonna be just y is equal to 1 minus, this is minus 1, so minus 1 multiplied by e power negative x, that's going to be just negative e power negative x. So this is the first solution. Now for the second solution, we don't have the initial condition, but initial condition is helpful to find out the particular solution. But if we don't have the initial condition available, because this region is above 1, right? We only have this one for 0. When x is 0, y is 0, that goes under this, because this region includes 0 to 1. But this region doesn't have 0 here because it's above 1. So there's no 0. So we cannot apply this initial condition to this one. But we can find out the general solution. Then we can find out the particular solution using the limit, because this says this is a continuous, find the continuous solution. So we are going to apply limit to that. But before we go and do try that one, let's go ahead and find out the general solution. Let's keep this one aside because we are going to need this one later in final answer. So let's get rid of all these things and let's start for the second one. Okay. Now for the second one, it's the same thing. First what we do, we write this one, dy by dx plus y. Now here f of x is 0. We are doing the second condition, right? It's always better to mention the condition when x is greater than 1. For the first one, you have to write when x is between 0 and 1, okay? So after we written this one, we put the differential equation. For this one, f of x is equal to 0. Now we solve this one in the same way. Since this is already in standard form, we looked at the standard form before. That's dy by dx plus p of x times y is equal to q of x. Now this is already in standard form, so we don't have to do anything. First we have to figure out what is our p of x is. For this one also, the p of x is 1 because we don't have anything in front of y. So p of x is 1. Then after we find out the p of x, we had to find out the integrating factor. That's e power integral of p of x dx. Since p of x is 1, this is going to be e power integral of 1 dx. That's going to be just e power x. Now after we find out the integrating factor, we have to multiply both sides of this differential equation with integrating factor. In that way we will derive dy over dx e power x plus y e power x. In the other side it's going to be just 0, because when you multiply anything with 0, that's going to be just 0. Now we see that if we do the derivative of this one, y e power x with respect to x, you will get the whole thing back, because this is a chain rule. That's why after we multiply by the integrating factor, the first term, we have to take the first term and equalize to other side. And that's going to be always going to give this one back in first order linear differential equation. And yeah, that's a chain rule, and you will get this one back if you do the derivative of this one. Now we found out this one, and now we have to integrate both sides with respect to x. Now if we integrate this side, derivative cancels each other, so we will get y e power x. And if you integrate a 0, that's going to be just a constant, so we can put it as c2, because before we got c1 and found out that's equal to -1. So this one we have to use a different constant. Let's call this one c2. Okay, now we have to figure out what is our c2 is, because we have expressed a particular solution for one thing, that for the first one, but for the second one we don't have the initial condition to find out the particular solution, so we have to do something for that. But first we have to write everything in terms of y. So in terms of y, this is going to be just c2 e power -x, because I'm dividing both sides by e power x. So here e power x cancels, and this e power x in the denominator becomes e power -x. Now let's go ahead and express our piecewise function right now. For the first one, we found out this is the equation we got, right? For the first one, we can express 1 minus e power -x is for the first one. if 0 to 1 f of x. Now for the second one, we found out c2 e power negative x if x is greater than 1. Now this is already, we found out the particular solution. For this one, in order to express particular solution, we have to find out c2. But here they have mentioned, if you look at the graph of this given function, it's going to look like this. When the region is, the x region is 0 to 1, it's 1. It means it's somewhere here. This is 1 and it's somewhere here. And after that, above 1, if it's above 1, this is 0. So it means we are going to have a line like this, right? But if it's continuous, mean this both has to connect in this region, right? We had to prove that one. In order to prove, we had to use the limit. We proved that when limit approaches, x approaches 1 from the right hand side, it's have an expression like this. So we had to prove that when limit x approach from 1 from this one, like above 1 mean right hand side, right? So right hand side should be equal to left hand side. If it's equal, then this is a continuous, so we can solve for this one. That's what we need, because they are asking to find a continuous solution. So in order to do that, first I had to prove that we want limit x approaches 1 from the right hand side, that y of x is equal to y of 1, because the discontinuous occurs at y of 1, right? So at that point we have to show that. Now here we know that y of x is right hand side. This is the right hand side. Right hand side is here. So instead of this one, we can replace that one with c2. We can say so c2 e power, instead of x I put 1. So this is going to be negative 1. And in the other side, y of 1 we already found out, that is 1 minus e power negative 1. Now from this one we can solve for c2. If you solve, this is going to be what, 1 over e power negative 1. That's because we have to divide everything by e power negative 1 to find out this equation for c2. E power negative 1, e power negative 1. So e power negative 1, e power negative 1 cancels. In the other side, e minus just 1. So c2 is equal to e minus 1. Actually, not power, this is e minus 1. Okay, now we found out c2. So we can express our final expression. Let's get rid of all these things. Okay, let me get rid of this one too. So from this one we can express our final answer. That's going to be just for the first one, it's going to remain the same, because that's the particular solution for the first one. 1 minus e power negative x if x is between 0 and 1. And c2 we found out that's e minus 1. So instead of c2 we replace that one with e minus 1. E minus 1 times e power negative x, and that is if x is greater than 1. And this is our final solution of this differential equation. I hope this helps. Thanks for watching. I hope you will check out my other videos on this differential equation, and see you next time.